So, legacy software. Can't live with it, can't live without, right? We all know this software that was written like 5 or more years ago in your company before you got there, statistically. And all the developers who wrote it probably left at this point, right? And now it's running on this EC2 or VMware or VM or maybe a bare metal on premise, and you hate touching it, right? Every time you touch it, you put the hazmat suit on because you're afraid that you will get all vulnerabilities on you. So nobody likes legacy services, right? So why won't we just delete it? And the reason you won't delete it is because we need it, right? Because while most of the companies are doing this awesome, amazing roadmap that will be running on these cloud-native technologies like Kubernetes and serverless, the reality is the thing that pays for it is actually this legacy, right? So legacy is actually awesome, and we need it. Now, so there are challenges, and instead of ignoring this legacy software, we actually should embrace it with all its challenges. And it's stuff like bad security, it's not always responding, right? It's responding slow, it's not compatible with our monitoring modern system. There's a bunch of stuff that we see every day. So I'm Lev, I'm CTO at Terasky, and we help our customers fall in love with their infrastructure and software by leveraging the right technologies and right methodologies. Doesn't matter if it's in Kubernetes or legacy. And today we're going to talk how you can improve your relationship with your legacy software. And we'll start by talking about a bit of challenges, and all this is kind of reference to Back to the Future. Hope some of you at least saw it. So many of our companies that we work with have compliances, right? Anyone here has to do SOC 2 compliance or PCI or HIPAA? Awesome, right? So usually when you do that, you have to do certificates. You have to do encryption in transit, right? And encryption in transit means you have to issue the certificate, you have to do it with the right organization, common name, you have to issue it in the right format. And then if it's Java, you have to import it into Java key store, right? And this is so much fun that everybody hates it. And usually they issue it for 10 years ahead, right? The certificate will be for 10 years. So statistically, it's a problem of the next DevOps guy, right? So this is what we see. So having some kind of certificate rotation could be awesome for our legacy service. The other thing is that we have error responses, right? From time to time, our legacy software, but not even legacy software, will respond with not 200 okay, right? It will respond with some error. And I'm not talking about like 418 time a teapot cute response error, right? I'm talking about 503, I'm going to die, give me a second. And those kinds of things actually require like a couple of minutes. Just let me retry it in a couple of seconds, it will probably be fine. So having a retry mechanism would really help. So there's another challenge that we usually have, and this challenge is a challenge of scaling, right? Because our legacy was developed 5 or more years ago, and it maybe wasn't great. And scale probably changed a lot during that time. So our software might not be able to actually handle the scale. Now, being able not to die is actually not that simple, but even more important that all other components that talking to our service can actually become slow because they're talking to slow service, so they exhaust their resources, right? How many of you are familiar with this idea of cascading failure? Cascading failure means that if one server is slow and whoever is talking to it is slow, now I have those services that become slow after the other and they just dying, and I have this cascading failure. And to address that, there's actually a circuit breaker pattern. I don't know if you're familiar with it, but circuit breaker means we will check during specific period of time if I have a failures to specific resource, and if I have, I will just stop accessing it and respond with error automatically. So this should save me from it. So we talk about a bunch of things, a bunch of kind of challenges and how we can solve them. And let's talk like what it will take to actually fix this. So we can do it in a multiple way. One of them is application. All I have to do is just take my legacy Java service and implement retry, timeout, and encryption. And the only problem is that many of the programmers left. So now I need to find programmers who can do it, who want to do it, and who hopefully won't break my profitable application. And many times it will be not only one application, but I probably will have PHP presentation layer or Ruby, so I have to do it multiple times in multiple languages. So I don't want to do that. What if I could do it once, right? So there is a way. I can do it once if I would do it with network, right? I can have my Java service talking to my Ruby service, and I just can put some kind of layer 7 load balancer in the middle that knows how to do encryption and retry and timeout. Easy. The problem is that those load balancers are actually super expensive, and they have to be super robust because it's now all the traffic, right? It's everything that goes east-west. And I probably need 2 of those, right? Because it can be single point of failure. Now, wouldn't it be awesome if we could kind of go into the future, learn how to solve all those problems, and just bring this knowledge into the kind of reality, right? So we actually have this. We actually can do it with Service Mesh. How many of you here know what Service Mesh is? Oh, okay, so some know. So basically what Service Mesh does is this. I would have 2 machines, right? I would have my VM1, VM2, and I would have a legacy service running on it. And this legacy has no idea about anything that happened in technology in the last 5 years. So it will send its legacy request to another server, and a proxy will take this request, and it will actually add all the smarts into it. It will add the retry, the circuit breaker, the encryption, everything, and it will send it to the next machine. On the other side, another proxy will take this request and unwrap it and decrypt it and do everything and forward it to our service B that has no idea that all those things that just happened. So I can have legacy on both sides and then actually enjoy from all the smarts that happened during like those last 5 years. Now, this is my data plane, those proxies. Now I need some way to control it. And this is why I will have a control plane, right? So this is what Service Mesh does. This is what everything you need to know about Service Mesh. Now, there's one additional great thing about Service Mesh. If you have, for example, duplicates between your duplicate IPs between a couple of VPCs or your on-premise and your cloud, because everything now happens on a proxy level on layer 7, we actually don't care about IPs. So now we can have duplicate IPs, and Service Mesh will actually solve this problem for us, which is super convenient. So you're probably asking yourself, why not use Service Mesh if Service Mesh is so awesome? And there's a couple of reasons, right? Reason number 1, it will take more resources. You're adding sidecar proxy, it will take more CPU because it's doing encryption, it will take more memory, it will take more resources. It will introduce additional latency, right? So it will definitely, it's more hops, so it will take more time. Maybe your legacy is perfect and you don't need to change anything, right? Unlikely, but it's possible. If your legacy is not perfect, then probably Service Mesh will be still better than alternative, even with throwing on it more resources and handling additional latency if you can allow it. So we're going to talk today specifically about console. And HashiCorp console, this is a DevOps Days talk, right? So it's an open source. And it exists since 2014, and it has more than 20,000 stars. And it's actually super robust. It supports more than 20,000 nodes in a single cluster. And it uses Envoy as a sidecar proxy. And Envoy is actually an open source project that is used for a data plane. So this is super common. Now, what are we going to actually build in the demo? So you kind of will see what are we doing. So we will have 2 servers, 2 VMs that will run a legacy software, Python on them. And we will have control plane for console that will actually configure the proxies on them. And we will have ingress gateway. All the traffic to our mesh will go through that gateway. And we hopefully will have my laptop in the recording. So now I actually need help with a video that will run, that will show the demo itself. Cool. So what you see is a demo magic that actually runs the command. And you can see that the first thing that I will do is I'm actually I'm actually opening AWS here, right? And you can see the servers that we have. We have the console server, Mesh Gateway, Marty McFly, and Dr. Brown. Those are our clients. The other thing that I'm doing, I'm opening console UI right now. So you can actually see that we have services, right? And we have the console itself, public ingress. This is how we get the traffic. And you can see that currently it's grayed out. I don't have Marty McFly registered at the moment. We will register it during the demo. And I have Dr. Brown service. Those are our nodes. Those are all the nodes that we have. And one of them missing a service. You can see 0 services at the moment. Now, the other thing is intentions. It's like firewall rules. I'm saying that everyone can talk to Dr. Brown and everyone can talk to Marty McFly. And I will show you how I will manage that later. So I'm just accessing my Marty McFly service and you can see the application is running. So you can see that the IP here, 99, and the one here is actually the same. All right, so now I actually embedded an error page in the application. It's error 500, and from time to time, it's actually responding with internal server error. So you can see that it's not perfect like any legacy. I also embedded a delay page, so you can see that from time to time, it's stuck for like 3 seconds. So you see, it's stuck now, and it's stuck again, and it's stuck again. But then it responded quickly on the other 2. All right, so I'm actually connecting to the machine right now. And what I'm doing is I will register and run the sidecar. I hope everyone can actually see what I'm typing here. So first, I'm showing what I'm listening on the machine. So we have port 22 and 53. This is our application, the Python. And we have console that listening on whatever console is listening. And again, I'm just confirming that this is still Marty McFly. All right, so this is what you need to know to register the application. You're just saying the name is Marty McFly. It's running on port 8080. And all this section saying we will have a transparent proxy running. That's all you have to know. I'm just removing the the demo part. And I'm restarting the console. Okay. Now I'm enabling the Envoy sidecar on the machine, and I'm starting it. Okay. So one of the things that it does, it actually alters our table. So you can see that first we get those ports, and this is Prometheus ports. So we get monitoring automatically for our application and its legacy. It knows nothing about Prometheus. It will also ignore all the traffic for console and Envoy itself as a processes, and it will just take anything that tries to escape the machine and just push it into this port 15,001. So I'm showing you again, those are the new ports that started with Envoy, and this is the port that Envoy listening to on. So all the traffic will just go into that port. This is what makes it transparent proxy. We don't need to change anything on the legacy application. Okay, so now we're going to access our ingress service. This, because now it's in the mesh, I'm accessing it through ingress. And you can actually see that this address of 161 is actually this address. And this is our Marty McFly through the service mesh, right? It looks the same, and this is the expectation. So first, I want to show you that now we have encryption. I'm doing TCP dump on a local host on port 8080. This is exactly what legacy would see. Legacy should see plain text. So I'm doing TCP dump. I'm doing a couple of retries here, going back, and you can actually see that we see the request itself and we see the response. Hi, I'm Marty McFly, plain text, right? So legacy has no idea that something is encrypted. But now I will actually show you what's going out of the machine. So this is going toward our ingress on the way out. So this is listening in TCP dump, and I'm doing exactly the same retry, right? A couple of times, going back, all gibberish, right? So all encrypted. Nothing was changed, no effort on R&D, got encryption, certificates rotated all the time. Every 3 days, certificates are rotated, not 10 years. All right. So now I want to show you how I configure application resilience, right? Because we want to actually have a resilient application. So first, this is Terraform configuration of console, and I'm configuring proxy default. I'm saying, please export all our Prometheus data on that port. This is how we get monitoring, zero effort, adopted to Prometheus. This is our circuit breaker configuration that says, this is what I allow, this is the interval, this is maximum failure. So circuit breaker pattern out of the box, no effort. Last thing is our retries. So I'm actually saying that every time you will go into this service and it matches / or anything else, please do 10 retries on any error code 500. And if a request is longer than 2 seconds, just cut it. So that's how we configure that, right? Super easy. So first of all, let's take a look at the console again. Now you can actually see that we have our Marty McFly that wasn't here before, and we have our public ingress that now actually forwards to registered service. You also can see that we already started getting monitoring that we didn't have before. I actually now have some data. But this is the interesting part, right? So let's do the retries to the error page, and I'm doing it 10 times intentionally to show you that it's not random. And you can see that it says that went well on Marty McFly, so it's actually working, and you can see that from time to time it takes more time because he has to do a couple of retries internally. But this has worked perfectly, right? Automatic retries on 500. And this is our delays. So you can actually see that it's being cut every time that we have more than 2 seconds. So instead of just waiting for some response, we're just cutting this on a timeout. The other thing that I want to show you is actually that it's not only working north-south, but also east-west. So I'm accessing from Marty McFly to Dr. Brown, and I got a response, right? But more interesting is our firewall rules that I mentioned previously. Now I'm going to intentions, and I'm saying, let's say that Dr. Brown or Marty McFly and Dr. Brown cannot talk. And I'm saving this, and I'm retrying that again. Exactly the same request. And now it's actually stuck, right? So I get firewall out of this and with no effort. And this is VMs, right? This is not Kubernetes. This is nothing. This is just east-west firewall out of the box. Now I'm removing this rule and I'm doing exactly the same request again. And you can actually see that it takes a while, but eventually it responds successfully, right? So this is the idea. This is how you get a lot of functionality in a legacy without doing any changes. All right, so in the meanwhile, you're probably asking yourself, what is a good fit for like, what kind of application? That's good. What kind of application would be a great fit for it, right? So anything that is HTTP, you will get all the functionalities that you see. You will get RBAC, you will get monitoring, you will get retries, you will get everything. Let me move. But even if you have TCP, and this is kind of your some proprietary TCP protocol, something completely old, you will still be able to get encryption, access control, and some of the monitoring, which is still better than nothing. Now, I showed you that it works on Linux VM, right? But it's actually also working on Windows VM, which is awesome, right? This probably covers most of our legacy. Maybe there's some mainframe, and maybe someday it will happen as well, but this is good. And it's first-class citizen for Kubernetes. So it actually covers our past, our probably present, and it also covers the serverless technology. This is not the right logo for Lambda. This is Lambda Labs, but it actually works on AWS Lambda. So this is pretty awesome. I think it's actually super powerful as a multi-platform service mesh. Now, I want to go back to the abstract of the talk. And everyone see today this approach where day 1, we install Kubernetes. Day 2, we do service mesh. Day 3, we may be connecting it to our legacy. And what I actually want to say is we can do service mesh today for any software, and it will actually make a lot of sense. And I'm sharing here with you another links, and one of them, the community office hours, is actually where Blake from Hashicorp explained in more details how to actually set it up. And I think you should see it. And as Dr. Brown said, future is what you make it. So make sure it has service mesh in it. Thanks a lot.